Okay, so today's video is going to be very interesting. Today we'll be talking about Planck's law. So, Planck's law, first of all, before we talk about Planck's law, we all know who was Planck, also known as Max Planck. Sorry, Max Planck, known as the father of quantum mechanics, quantum physics or mechanics. Father of quantum mechanics. I don't have to add that. Okay, so when he had, he made an equation n equal h this wait sorry n 8 pi over c3. So he said that a stationary wave okay, a stationary wave can, this is what mode calculation is about of stationary wave. This stationary wave, radiation of the stationary wave shows, wait, let me write another equation. This is okay here. So we are talking about black body radiation here. Our main topic will be black body radiation. Black body radiation. Okay. So here we'll be talking about black body radiation in terms of that an object. Here we're talking about a simple harmonic oscillator. So with using simple harmonic oscillator, we'll be talking about black body radiation. This n is the mod of this wave, the standing or the stationary wave. This is how we calculated the stationary wave, and it's an accurate one. So to get the to get what we say the black body radiation in terms of frequency and time, we just have, if you want to get the black body radiation, U is black body radiation. So if you want to get the black body radiation of the standing wave or this oscillation of a simple harmonic oscillation or oscillator. Okay, this is black body radiation. Okay, so what we get to get this, what we need is we just add or we just combine n, the mod, with energy. Okay, we just combine these two instead of writing this, we combine. So when we combine them, we get U in terms of black body radiation, in terms of frequency and time, we get 8 pi of h is Planck's constant, frequency square over c cube. Some places instead of writing f, they write f is mu. It's the same thing, so it doesn't matter, but here I will be using f. And when I combine this, I get, let me extend this, it's where is it, kt. Okay, so now This is how we get black body radiation of a frequency, certain frequency, with energy kT. This energy, one more thing, this energy kT was calculated using classical physics, and this will be a problem later on. Classical physics. How it's a problem? How it's a problem is that if we study this equation to 8 pi h frequency squared kT over 3 cube c cube, we get something. The energy is infinite when our frequency f square increases. Okay, increases. This is what happens, and this is a disaster because infinite is not possible. It has limit. So then Max Planck was shocked. He had to study more and more about how we can solve this and what was the problem. But then two physicists, when they said that the energy, the black body radiation or transfer of energy can happen at a continuous rate at like every single value, like every single 1.11, 1.2, 1.3, so on. But then Max Planck said no. What he said? He said no. That energy can only change in discrete values. This was the groundbreaking change that he discovered, that energy can only change in discrete unit, not in continuous rate, and not at continuous rate. Okay, so then he changed his way of thinking. Okay, now we're talking about from classical physics, because this is a wrong method. Now this didn't work. The method was wrong. So as here energy is continuous, the change in energy is continuous. But here, so if I want to give the example of change in energy is continuous, how I can give the example is like this. Let's suppose we have an element, okay, any element, and assuming it has why not hydrogen? Okay, now or hydrogen, any other element. So if that element has 3 electrons in its outermost shell, 3 electrons in its outermost shell. Sorry, not outermost, in its shells. Okay, one here, and one here, plus it has one more valency. This is just an example. Okay, so if this sorry, wait, let me change color. If this electron gets higher in level and lower in level, here it will only get higher in level. If it gets higher in level, what will happen? What will need to happen? It will need energy. It needs energy to increase in higher in level. So how it can happen? We give it h frequency, which is what? Photon. This is photon. Okay, so when we give it photon, the result will be result is outermost shell will now have this electron, empty outermost and then here not empty now. So then this is how we can say, because here the particle is increasing. Wait, let me write here, or let me just write here in proper way. Particle, or here we have electron, is increasing in levels. This is called energy levels, from 1 to 3 to 3 to 1, not 1.1, 2.2 to 2.3, and so on. Okay, so then when we talk about more things about Planck's constant, so this method over here, this is correct. What till here, the mode calculated using the mode calculator of this oscillation is correct, but the problem arises in this, that energy is not continuous, it only changes in discrete values. So then now the equation, this equation what we used here is what we will be using in a future, now after this as well. Now E equal wait, so yeah, E equal HV, but the most proper equation is actually E equal NHV. Okay, if we rearrange it, it can be E over N equal HV. N is what? A natural number of frequency, okay. So after that, we can combine this with another concept, that we can calculate